Today I would like to show you how to estimate vector autoregressive model including a dummy variable or a VAR model with a dummy variable, and I would like to show you to test whether this dummy variable's inclusion is significant or not, or we should keep this dummy variable or not. So we will estimate two models today. One is called restricted model and another one is called unrestricted model, and then we will use LR test, which is usually used. This is the LR test formula, which is usually used to test whether to keep the dummy variable in the model or not, and I will come back to this later during the video. Now I will have four variables, four series from among these variables, and my dummy variable is here, this variable, and this dummy variable is for this 2008-06 and 2000 month 10 period. And the reason for this dummy variable is the lnmkt variable, which will be my dependent variable in one of the models in VAR, in one of the equations in vector autoregression model. So this is the reason I'm including this. I'm trying to see if I should include this dummy or I should have dummy for this sharp decline here. It's a sort of a structural break, or you could actually say it mightn't be. However, this period corresponds to the financial crisis that occurred in Europe, and this is for Brazil. So, and this is the variable for Brazilian market index, stock market index. I think it was Bovespa, I can't remember exactly, but it is the Bovespa stock market index, and it also was declined. It actually sharply declined within 4 months time to a lower level here, lowest level, and then markets calmed in Europe and America, and then also their market also started increasing here, going back to normal period. Now this is the variable that I said I want to account for the I want to account for this decline here in the equation in this variable. Sorry. Okay, we'll go to variables that I want to take. This variable I want to take, and I want to take this variable, and also I want to take this variable and this variable, and I will open them as a group. Now usually you do the unit root tests to see if the variables are integrated, and if they are integrated or the one or if they are integrated of the same order, it's better to use it is advised to use co-integration, or to test for co-integration and estimate vector error correction model rather than vector autoregression model. Now I tested them earlier, and LNFF is integrated of order 0, or in other words, it is stationary. The rest is integrated of first order 1. That's they have unit roots. This one doesn't have the unit roots. So what I will do, I will take the differences of these in my model, but I leave the LNFF as it is, because this is a stationary model integrated of order 0. Okay, now I'll go to proc and I'll make vector autoregression. Here is the menu. So we are going to use unrestricted VAR option, and here I need to take the difference of the first variable, difference of the second variable. You could actually pre-create these variables, like generate these variables yourself, differences yourself, but I prefer this method. Now because if I create different variables, it will actually increase the number of variables here, and then I will have to look for the variable I need carefully here when I need it quickly, so it takes time to find them among many other variables. So now we will also assume that I tested it earlier using the lag length leg length criteria, that it needs 12 leg. I made the video how to choose leg length as well in my other videos, in my other sessions, so have a look at them in my channel. Like 12 legs here, and the sample period is from 1996/01 to 11/12, month 12. So this is 2011 month 12. Now I will first estimate my restricted model. Unrestricted model. Unrestricted model will include the dummy variable. So we won't include the dummy variable here. We don't put them because it's not an endogenous variable, it's exogenous variable, so we go and put it here. And my dummy variable, if you remember, is dummy 0809, so D 0809 comes here, and C is going to stay there. It's a constant. We need the constant according to the characteristics, or based on the characteristics of my data, we need a constant there. So this is the place for dummy variable. So now I'm going to estimate my vector auto regressive model, and this model will be unrestricted model, which includes the dummy variable, and I'll press OK. And I think I presume this is correct. Rather than presuming, I will double check it. So ln IPI, ln bro P, ln market, ln FF, 12 flags, and all done. Okay. Now this is my VAR with 191 observations, and for the sample period, and I have all these 4 equations here, and I have my diagnostic tests. And usually you should test for residual autocorrelation, normality, and White's heteroscedasticity, but I've done it earlier, and I have shown this in my other video how to do that to save time, so I will assume that it's all fine. We passed it all. We passed all these diagnostic tests. Now I don't need this output at the moment. What I need is this output later, so I will have to save this. So I will name this model, this var, as var unrestricted model. Okay, now I'll close this. If I need it, I can click there and then get my saved model with the dummy variable. Okay, now I will have to do the same. I'll have to create another model with the same number of variables, by this time without the dummy, because this time I'm now estimating the restricted model, which is the model without the dummy. So basically I will do a test which compares the model with dummy and without, and then tells me which one is better. So this is the bottom line of this model, or the thing, the process in a nutshell. Basically the process in a nutshell is that we compare the restricted, unrestricted model, which has the dummy, with the restricted one, which doesn't have the dummy, and then the test result shows us that whether to which model to go with, to go for, which model to use in our analysis. Okay, now restricted model is without the dummy, and as you can see, I'm not including it here, and I have 12 flags, and I have exactly the same number of variables and the same variables here, and unrestricted var the same sample. So click OK, and I have the similar output, but without the dummy here. As you can see, in this var I had the dummy, so I will also save this as var restricted. Okay, that's done now. Now next step is we don't need this, we can delete this. Next step is now to calculate the LR statistic. LR statistic is calculated using this formula, and the statistic here that you calculate is just a number which is distributed asymptotically chi-squared. Basically the values that you compare this statistic against comes from this distribution, chi-squared distribution. So LR test is value is compared against the values of this statistic at some probability value or probability level. Let's say 5% probability level, significance level, let's say. So I need to now estimate this, calculate the value here. Now T here is the number of observations. In our case it was 191, so I forgot to put here. So T is the number of observations. M is the number of parameters in each equation. So in our case we have constant plus the parameters that we how many legs did we include? 12 legs. So we'll have 12 parameters for the 12 coefficients plus one constant in each of the equations. So that's what it is here. Now the sigma here, each sigma here, this one is a restricted sigma and unrestricted sigma. Restricted sigma is the residual covariance matrix determinant, or determinant of the covariance matrix of the residual. So I will show you what we mean by this in a few minutes when I go back to the e-views. Now the Q here is the number of restrictions, or sorry, it's not restriction, it's the degrees of freedom in chi-squared distribution. So that is equal to number of dummies I'm including in this in my VAR model times the number of equations. So number of dummies I have here at the moment is 1. I'm including only one dummy for the whole model, and I'm using this for each of the equations, and I have 4 equations because I have 4 variables, or 4 series basically. So we will now use this test to to this formula to calculate LR test. Okay, now let's go back here. Now I will do it here so that it's visible to you as well, and it's everything is visible from e-views menus. So I will now open my which one is this? This is a restricted one, which will have no dummy, and I'll open the unrestricted one, which will have the dummy. So this is what I need at the moment, and I need the bottom part of the model. Now if you remember, there was sigma in the equation, and let's put the equation here just in case. That is equal to LR stat is equal to bracket T minus M times the ln sigma sigma minus, so this sigma for it's for restricted model, model, and ln logarithm of natural logarithm of sigma of unrestricted model. Okay, now let's put square brackets to make it easier. Hopefully this is visible to you, otherwise you'll have to zoom. Now this is the equation I need to calculate here. Now sorry, we'll don't need this one. Now my t is equal to what was T? 191. Double check this. Yeah, number of observations after adjustments is 191, so that's 191. Now my M will be equal to number of equations times the number of legs plus the intercept. Intercept is always in each model is 1, plus I forgot something, is the number of dummies I'm including, so it's extra 1. So m is equal to number of variables or number of equations times the number of legs in each equation plus the number of intercepts you have plus number of dummies. So altogether equal to 48 plus 2 equal to 50. So we have 50 parameters in our model. Now, interesting part here. What is sigma restricted now? What is the sigma? And this, I said, it's the residual covariance matrix or matrix in easier pronunciation. Now, how do you get this? You usually go to view residual and click on covariance matrix, and here is the covariance matrix for the residual. Now you need to calculate the determinant for this, and if you know, matrix determinant takes a little bit a long time, and it has a formula basically to calculate this, but this is how you get this actually for this model, for the current model, for the unrestricted model. So you go to views, residual and covariance matrix, and it will show you all of this. Now we don't calculate it manually. So we don't calculate it manually. It will take time to calculate the matrix determinant, but usually determinant of the residual covariance is given here. This is for the unrestricted model, here is given already, and for the restricted model it's here, this one. So we have already got them, so we don't need to estimate them. So what we now do is we just simply insert the values into the formula here. So t is 191 and minus m, and m is 50 bracket times the square bracket ln of this value, restricted, it should be this one, yes, it's the restricted value, which is this, copy this, minus ln of the unrestricted determinant of the covariance. Now I need to now do a little bit arithmetic here. I will now use a spreadsheet here to do that. Should I copy this? Yeah, hopefully it will work. Okay. Now it doesn't work with the square brackets, so I will have to change the square brackets to rounded proper brackets. Okay. An error, so it found an error here. What sort of error it is? Yeah, I see what it is. Alien. So I will type this actually. I will type it. So how much was it? 2.21 e minus 13. So it has 13 zeros after the decimal, so we don't have to write all 13 zeros, so I hope it does. So 21 now. Okay, so this is now my LR statistic here. I will copy this and put it here just in case we need for the comparison with the chi-square table later, so that I don't have to go back to the spreadsheet again. So this is what we calculated for LR. Now I will now have to estimate the degrees of freedom for the chi-square values. So chi-square degrees of freedom is equal to, if you remember, number of dummies, in our case it's 1, times the number of equations, in our case it's 4, because you have, if you look at this, 4 equations. In each case, 4 variables makes 4 equations. In each case, each variable is an independent variable. So dependent variable, sorry. So it's 4 degrees of freedom. Now we have to now get the chi-square table. chi-square distribution table. So we will now look for chi-square value, critical value in other words, with probability of 0.05 or 5% significance level, in other words with 4 degrees of freedom. So I have actually opened it in my browser here. So 4 degrees of freedom at 5% is here, p equal to 0.05 for 949. So I'll copy this. 4 degrees of freedom for 9.49 is corresponding to 5% level. So now I'll go back to my original eViews output, and now I will compare it with my statistics. So my statistic is greater, which is 21.31, than chi-squared critical value 9.49. So what we do here in this case, we reject the restriction of no seasonal dummies. So in other words, we are rejecting the null hypothesis. And in fact, I forgot to tell you what is null hypothesis. Null hypothesis is no seasonal dummy. Oh, sorry, not seasonal dummy. No what dummy? No financial crisis dummy. Or null hypothesis, in other words, no effect of this value. But in fact it actually has an effect in this model, because our test statistic is greater than critical value, and we reject the null hypothesis of restriction of no financial crisis effect. Okay, so with this I demonstrated you how to estimate a VAR model using a dummy, with a dummy variable, and I also explained you how to test for the importance or significance of this dummy variable. So in this case we have to include and keep the dummy variable and estimate the whole model with this dummy variable, because of the LR test statistic that we estimated, and this is actually log likelihood ratio test here. Now if I made any mistakes in this video, please leave comments. Brain might malfunction anytime, because you will be dealing with different things in your mind while speaking here. So always you're welcome to leave comments, and if you have any questions you can leave them as well there, but I don't promise you that I come back to you with an answer, because I don't usually check the comments, or even if I check things that you ask, I mightn't know. So if I know them, I will try to answer. Even if I don't answer them, please search the web or relevant books, and I'm sure you will find the answer. Okay, I hope this video is helpful to you, and I will make more videos on VAR and VACM later, depending on the time. Bye then for now.